25 milliliter of hydrogen and 18 milliliter of iodine vapors were heated in a sealed tube at 456 degrees centigrade. When at equilibrium, 30.8 milliliter of HI was formed. Calculate the degree of dissociation of pure HI at 456 degrees centigrade. Now temperature and pressure conditions are constant. So volume is directly proportional to number of moles. Here N denotes number of moles and V denotes volume. Now the equation is H2 plus I2 forming 2HI. Initially 25 ml of H2, 18 ml of I2 were present and amount of HI was 0. Now suppose X milliliter of H2 reacts with X milliliter of I2 to form 2X milliliter of HI, because according to the balanced equation 1 mole of hydrogen reacts with 1 mole of iodine to form 2 moles of hydrogen iodide. Now since volume is directly proportional to number of moles, we can also say that X milliliter of hydrogen reacts with X milliliter of iodine to form 2X milliliter of hydrogen iodide. So hydrogen remaining is 25 minus X milliliter and iodine remaining is 18 minus X milliliter, and hydrogen iodide formed is 2X milliliter. Now the amount of hydrogen iodide formed is given as 30.8 milliliter. So 2X is equal to 30.8. Therefore X is equal to 30.8 divided by 2, that is 15.4 milliliter. Now putting the value of X, the amount of hydrogen remaining is 9.6 milliliter and amount of iodine remaining is 2.6 milliliter. Now to calculate Kc, concentration of hydrogen iodide divided by concentration of hydrogen and iodine. Now concentration of hydrogen iodide is raised to the power 2, as 2 is the stoichiometric coefficient of hydrogen iodide in balanced equation. Putting the values and solving, the value of Kc is equal to 38.01. Now in the question it has been asked that what is the degree of dissociation of pure hydrogen iodide. Now degree of dissociation means what is the amount of hydrogen iodide dissociated out of 1 mole of hydrogen iodide. Now according to the balanced equation, 2 moles of hydrogen iodide dissociates to form 1 mole of hydrogen and 1 mole of iodine. Now if initially 1 mole of hydrogen iodide is present and 0 moles of hydrogen and 0 moles of iodine is present. Now if X dash moles of hydrogen iodide dissociates, then X by 2 dash moles of hydrogen and X by 2 dash moles of iodine will be formed, because amount of hydrogen and iodine formed is half of the hydrogen iodide dissociated according to the balanced equation, and the remaining hydrogen iodide is 1 minus X dash moles. Now again calculating the value of Kc dash. Now Kc dash is the value of equilibrium constant for this reaction, which is the reaction for the dissociation of hydrogen iodide. So it will be inverse of Kc, that is 1 by Kc, and this is equal to 1 by 38.01. Now putting the values for the concentration of hydrogen, iodine and hydrogen iodide and solving, the concentration of hydrogen iodide is raised to the power 2. Now solving, the value of X dash is equal to 0.245. Now percentage dissociation will be out of 1 mole 0.245 moles is dissociated. Therefore out of 100, 24.5 moles will be dissociated, or the percentage dissociation will be 24.5%.